So you can go to the drawing that we created in last exercise. And if you couldn't find your last exercise, you can actually go in the EasyEDA and write the name of this last exercise on the search window. I have published my last drawing. So what we did in the last exercise, I have published it, and you can find it from there. And now we continue by creating there another connector. This is for the OLED display. And then we go and take a connector again. So into this library of all kind of most common interfaces, we take an socket header. So we have the pins in this module. And take a header. It's in this header female, 20.54 millimeter bits, 1 times 6. We need 1 times 6. That one. Bring it in here. Escape out of this tool. And with the right clicking, we can edit the symbol. And we can actually name it also that this is our PmodALS. And then we can name the pins. So there are the pin numbers from 1 to 6. And in here, we can see that this is the pin number 1. So the pin number 1 is the zip select. And pin number 2 is the not connected. Pin number 3 is the serial data out. I would name it master in slave out. Now it is the serial data out from the sensor. Then there is the clock. So this is the SPI clock. So, okay, clock, SAK. Then the ground pin. And the operating voltage pin, VCC. Looks like this. And then how to connect into the microcontroller. So the wiring tool from here. So the ground and the VCC. What is this? So I would take the ground pin a little bit. Oh, sorry. I'll go out of this wiring tool now with the escape and select the ground wire in here. And now it looks a little bit more like in the laboratory if we take the ground line down here, so that we have the ground line down here and everything we need to connect to the ground line, we connect down there. Also, that one I would like to draw down in here. Did it work? Not necessarily. Yeah, it works, I think. Does it? Yeah, it's connected. Looks like. Right. Should be connected at least. So the ground line is down here. Everything we connect to the ground is down here. So also the ground from here, wiring tool, the ground from here goes down here to the ground wire. And then the operating voltage VCC 3.3 volts. We do the same for this. So actually I'm selecting this line, this 3.3 volts line, and I'm taking it down, down in here. These were connected to the operating voltage. And that was connected to the operating voltage. So down here. Like this, we have an operating voltage down here, and everything we need to connect there goes down to the operating voltage. And then, so the VCC to the operating voltage in here. And then the clock signal is exactly the same as the clock signal was for the OLED display. So if we don't remember that, how was this connected in the L432 circuit, we can have a look from the PmodALS and the hardware boards and the L432 KC and search. It's this one. And the document on what pin in here. And we can say that the SPI interface, the clock signal is the pin number 13. So we go to pin number 13. With the clock here, we go to pin number 13. How to find a route there? I think that's all right. We go to the same pin, like that. And then there is the master in slave out. We need to have a look at what is the master in slave out. And the master in slave out is that one. Master in slave out, D12. D12, that side, how to get there? Oh, okay, there is a. I'll move that line a little bit that I have space to draw the other one. And then the master in slave out. To D12. What else? Then there is the not connected, and then there is the shift select. NC refers always to not connected. Shift select, that's the pin that the microcontroller tells from a normal digital output or a pin it can use as a digital output. It is telling that I would like to communicate exactly with that chip. And for that purpose, I will use now one of the pins on this side. So actually, this is an analog to digital converter pin, but these pins can be used also as a quite normal digital inputs and digital outputs. So I'm taking one of these. I'm taking the A6 as an output now. So I'm not using it as an analog to digital converter, but I'm using it as an output pin. In the code, I can refer to it with this name. So back to the zip select drawing in here. So drawing the zip select line. So we have this zip select. And this time we take the zip select from one of the analog pins, and we take it from the analog 6. This is also always odd from which way you draw your lines. So you can draw it anyway. I mean, this software is just creating a mathematical model from the connections from this pin. This is the node in the mathematical model, the pin end, and then to this pin end here. That's another node. And it's in the mathematical model of this design. It's just like a table format that these pins are connected. So it doesn't matter which way you draw these. So the function is the same. Even when the printed circuit board is created out of this drawing, it doesn't matter which way you have drawn these lines. Also, data going to the printed circuit board creating software is just the table format of which pin is connected to which pin. It hasn't got the information which way it is routed in here. If you go the other way around of the circuits, it doesn't matter. All right, now we have connected the ambient light sensor. And when you create this same circuit in the testing board, we can just connect the ambient light sensor module in this connector, and then you modify or create the code, and then it should work.